optical phenomena are established only when light is considered to be a wave. The characteristic nature of a metal. What is the significant nature of a metal? But easily cannot come out of the metal. Why? Therefore, very cautiously, they concluded that light. Hello students, a new dawn, a new day, a new session. Let us start this new session, this new topic by following up this quote. Understand, dear students, success is an outcome of the attitude of thinking, and all of us should learn what to think and not how to think. This is your SD sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Today, having a discussion on a new chapter, what is called dual nature of matter and radiations. So we pop up understanding the word dual nature of matter and radiations. My dear students, the very word dual means two. ಎರಡು ಮುಖ ಅಂತೀವಲ್ಲ, two-sided, two-faced, pair. So, very much the word dual refers to something called two-sided. And read the caption very carefully. It is dual nature of matter and radiations. Nothing to do with dual nature of light. I am exclusively understanding, impingingly focusing on the two-sided nature of matter and radiations. What is this dual nature of matter? What is this dual nature of radiations? We will slightly cling on next and now have this introduction. Follow, students. Light initially, basically, was treated to be a wave. People very well knew that light propagates from one medium to another. Light also travels in vacuum, exactly like a wave. Therefore, very cautiously, they concluded that light is a wave. Stamp otbutru. Nature of light was exclusively concluded to be a wave. But when Mr. Einstein jumps into the field with photoelectric effect, people believed that light also exhibited particle nature. Very surprising. Initially, light was treated to be a wave, a religious confirmation on the nature of light, that it is a wave. But people like Maxwell, Planck, Einstein very authoritatively established that light is also a particle, and hence within quotations they told light has dual nature. Light has two faces in it. It is a wave and also a particle. ಎರಡು ನೇಚರ್ ಇದೆ ಲೈಟಲ್ಲಿ, ಎರಡು ಮುಖಗಳು ಅಂತ ಕರಿತೀವಲ್ವಾ, ಅದೇ ರೀತಿ ಎರಡು ನೇಚರ್. ಲೈಟ್ ವೇವ್ ಆಗೂ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ, ಪಾರ್ಟಿಕಲ್ ನೇಚರನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. ಆದ್ರಿಂದ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ ವಿ ಟೋಲ್ಡ್ light has dual nature. Now the question was, when will I consider light as a wave and when will I consider light as a particle? ಯಾವಾಗ ಲೈಟ್ ನ ವೇವ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಯಾವಾಗ ಲೈಟ್ ನ ಪಾರ್ಟಿಕಲ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ? ವೆರಿ ಸಿಂಪಲ್. ಇಫ್ I have to explain optical phenomenons, for example, phenomenon of interference, phenomenon of diffraction, polarization, I have to consider that light is a wave. ಯಾವಾಗ ಲೈಟ್ ನ ವೇವ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಆಪ್ಟಿಕಲ್ ಫೆನಾಮಿನನ್ಸ್ ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕಾದ್ರೆ, ಇಫ್ I have to explain interference of light, diffraction of light, polarization of light, I have to consider light is a wave. If I consider light is a particle, then these optical phenomena cannot be explained. On the other hand, if I have to explain the phenomenon of photoelectric effect, what Mr. Einstein gave us, Raman's effect, Compton effect, then I have to consider light is a particle. If I attribute wave nature to light, these phenomena cannot be explained. Therefore, understand, kids, it is the phenomenon which I am trying to explain, I am considering, makes me treat light as a wave or a particle. All optical phenomena are established only when light is considered to be a wave. All particle phenomena like photoelectric effect, Raman scattering, Compton effect can be explained when light is treated to be a particle. So very much without any ambiguity, without any confusion, now we say that light has dual nature. Light is two-phased. It is a particle as well as a wave. If so, now people started questioning that matter, which is moving particles, can it behave as a wave? When light, which was treated as a wave, can behave as a particle, can particles in motion behave as a wave? And the answer was yes, which will slightly be established in the later part of the chapter. Now, proceeding with the discussion, the first concept that we understand is electron emission. Emission of electrons from a given metal surface. Now, I consider a metal surface, some metal surface. When I talk about a metal, the characteristic nature of a metal, what is the significant nature of a metal? It consists of free electrons, abundance of free electrons. Given a metal surface, there are large number of free electrons. Yen free electron andre electron which is not under the influence of the nucleus. It is in an orbit far away from the nucleus. It is not administered by the nucleus. That electron is called a free electron, and a metal surface consists or contains large number of free electrons. Now, electron emission, the phenomenon of removal of electrons. We are removing free electrons. We are liberating free electrons from a metal surface. In simple words, is called electron emission. Emission of electrons. Two other words which means emission is removal or liberation. So removal of free electrons or liberating the free electrons from a metal surface is called electron emission. But the question is it so easy? Is the phenomenon so simple as defined? ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಒಳಗಡೆ ಕೈ ಹಾಕಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ತೆಗಿಯಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲ. ವೈ? These electrons are under the control of surface forces, or they are also called refraining forces. It may be a free electron. It simply moves in the volume of this metal, but easily cannot come out of the metal. Why? It is controlled by the surface forces, or which is also called refraining forces. So to liberate the electron or remove the electron from a metal, this surface or refraining forces has to be broken down. ಒಂದು ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದು ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಲಿಬರೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ, ರಿಮೂವ್ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಸರ್ಫೇಸ್ ಫೋರ್ಸ್ಗಳನ್ನ, ರೀಫ್ರೇನಿಂಗ್ ಫೋರ್ಸ್ಗಳನ್ನ ಸಾಯಿಸಬೇಕಾಗುತ್ತೆ. ಇವೇ ಎಲೆಕ್ಟ್ರಾನ್ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಹಿಡಿದುಕೊಳ್ಳುವಂತ ಫೋರ್ಸ್ಗಳು. So how do I break these surface forces? By supplying some external energy. You have to give the electron some external energy. ಬಂಡಾಯ ಎಬ್ಬಿಸಬೇಕು ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿಗೆ ಹೊರಗಡೆಯಿಂದ ಚೂ ಮಂತ್ರ ಬಿಟ್ಟು. So I have to excite the electron by providing some external energy so that the surface forces, the so-called refraining forces, break down and the electron comes out of the metal surface. And this entire phenomenon is called electron emission. So, in simple words to understand, it is the phenomenon of removal of electrons, liberation of electrons, knocking out of electrons from a metal surface by supplying suitable external energy. And the external energy you supply may be in the form of heat, maybe in the form of electric field, radiations, etc. And depending on what type of energy is supplied, we have 4 types of electron emissions. The first one is called thermionic emission. The name itself will define thermionic emission. This is thermal ion emission, where we clearly know thermal means heat. So here, in such kind of electron emission, the external energy supplied is heat. So phenomenon of liberation of electrons by supplying heat to a metal surface or from a heated metal surface is called thermionic emission. Heat the metal surface, supply external energy in the form of heat. electrons are liberated. That is what is called thermionic emission. So, at any temperature, any mean temperature, you supply heat. Is it possible to remove electrons? No. Here, heat has to be supplied at a temperature, very high temperature of 2500 degrees Celsius. Only then liberation of electrons take place, and the electrons which come out of the metal surface is called thermions. So what is thermionic emission? Thermal ion emission. Here, heat is supplied at a very high temperature, 2500 degrees Celsius, to remove electrons from a metal surface. Next one, field emission. Exclusively the external energy in the form of electric field. So the phenomenon, the process of removal of electrons from a metal surface by applying strong electric fields, field emission, strong electric fields. How strong? In the magnitude of 10 power 8 volt per meter is called field emission. Beautiful phenomenon. Here I talk less about this because it is discussed as a single chapter next. Photoelectron emission. The word photo refers to photon, which is nothing but light. So the external energy supplied is light. So it is the phenomenon of removal of electrons from a metal surface when light of suitable frequency is incident on it. I talk less here, more in the next discussion. Secondary emission. Idan primary emission barle illa, secondary emission agoitalla. What is this? Process of removal of electrons from a metal surface by striking it with fast moving electrons. Illi fast moving electrons metal surface alliro free electrons na liberate madak upayogiskoltivi. The incident electrons are called primary electrons. The fast moving electrons which strike the surface, they are called primary electrons, and the liberated electrons is called secondary electrons. Thereby the emission is called secondary emission. ಏನು ಮಾಡ್ತೀವಿ? Fast moving beam of fast moving electrons strike the metal surface. These incident electrons are called primary electrons. Now what do? They provide sufficient energy for the free electrons to come out. Therefore, the liberated electrons are called secondary electrons. So students, very clearly you see, depending upon the nature of the external energy supplied, you have thermionic emission, field emission, you have photoelectron emission, and you have secondary emission. Now, as I told, discussing a beautiful effect, photoelectric effect. Very, very beautiful. This can also be said as photon electron effect. So photoelectric effect is beautifully understood as photon electron effect. Now, again, I have a metal surface which has a free electron. Now, the external energy used is photon, which is light. Now, we say when photons or light of suitable frequency, credential word to understand photoelectric effect. When light of suitable frequency is incident on a metal surface, electrons are liberated from that surface, and this phenomenon is called photon electron effect, or in terms photoelectric effect. Phenomenon of removal of electrons from a metal surface. When light of suitable frequency is incident on it, is called photoelectric effect. Photon is liberating an electron from the metal. Therefore, it is photon electron effect. Why suitable frequency? We will just hold our anxiety to the next session. This phenomenon was discovered by the scientist Heinrich Hertz. Now, most of us have a misconception that Einstein discovered photoelectric effect. No, Einstein beautifully explained the mechanism of the effect, but actually, accidentally, photoelectric effect was discovered by Heinrich Hertz, and these electrons which come out, they are called photoelectrons. So, a photon, light of suitable frequency, falls on a metal surface. Immediately electron is knocked out. It becomes a photoelectron, and the phenomenon is called photoelectric effect. In my next session, we will beautifully understand Hertz's experiment on photoelectric effect and consequences of the experiment. I hope the introductory session is quite convincingly reached, y'all. Let us meet next. Until then, have a good time. Thank you.